Please join my channel Han Solo Engineering on YouTube. It is a new channel, but I really want to just basically put a lot of free videos on, because I couldn't ask my lecturers anything almost in certain subjects now. So the qualified guys don't need to watch this video. We'll start from the basics, from square one. Okay, so when you have a residential installation, you normally have single phase. I'm going to cover single phase only because three phase is pretty much the exact same thing, but except you have three lives and you're neutral, be it the case of a residential house. It's essentially three lives are just out of phase. So they're short if you touch them, like phase to phase. I don't know how to put it. It's even worse than phase to neutral. But yeah, besides that, there ain't much about it that's that different. The municipality will have a kiosk. From that kiosk, they will lay a cable, generally 16 millimeter, sometimes 10 millimeter, and they will provide you with a cable which you fill a form in by the municipality for your meter if it's a new installation. Normally your IE can fill it in for you. He has to be registered at the DOL. All right, so then you can get your meter, you can pay for your meter, and then of course have them basically provide you with a cable. So you start off with a new installation with that cable to the distribution board. 63 amp double pole circuit breaker would be your ampacity of the generalized residential sector. This is just a average. You do find people that stay in like 45 amp. This is just a generalized house. If I go to this flat, or if I go to most houses, what do I see? A distribution board, a 63 amp main, right? Main circuit breaker. A lot of sparkies get this completely mixed up. And you can have an instantaneous current or near instantaneous current before your circuit breaker drops out. Have a 6 kA installation and you're using a 3 kA, you might find it burns out, and then you're like, oh, but it was also 20 amps. But the problem is it's shorted underneath it. So it's shorted at 6 kA. It wasn't rated for 6 kA before trips. The bimetallic strip cuts it out, or whatever circuit breaker you're using, there will be a delay. And basically, if it's not rated for the KA for what you test with your PSC testers, you will basically be able to test what it potentially shorts at. This will not be 100% accurate. Of course, it's a meter showing you what it thinks it will short circuit at. But it's pretty close. So you can size it, you can test it, and generally you want it to be larger than the PSC of your installation. There would be a safety margin. Normally a safety margin of like at least 1 kA I would assume is safe. Other sparkies have told me they size it by double. Yeah, it's a little bit of a problem sometimes, especially when you're dealing with like a 5 kA and you can pretty much safely use a 6 kA. I'm not gonna go size it at like a 10 kA, you know what I mean? So that's just me personally. I know everyone will be like, oh, shoot my head off, but then do, that's just my take on it. All right, so that's PSC of your circuit breakers, right? So let's go and look at what a circuit breaker is. This is a 10 amp circuit breaker over here, but your one that you'll be using for residential sector would generally be a 63 amp that looks exactly like this. Generally, people are using DIN rail, what they call DIN rail. Basically translate to thin rail, and it basically is the circuit breakers that clip in the middle on a little rail like this. The rail basically, let me clip on one for you quickly so you understand.